Okay, so here are the basic steps in the scientific method. You observe some phenomena, you formulate hypotheses and predictions, you test these hypotheses through empirical research, remember, through direct observation of real-world phenomena. You draw conclusions from the findings you get, and then from those conclusions you can then go back and look at the theory that may be behind all of this, either be building the theory or perhaps tearing down a theory that might have been disproven. So this is what you do, and this process continues again because the theory would then essentially spur another researcher on to then point to the specific phenomenon and try again to conduct another study. So let's start with observation. The first step is to observe. Well, scientists are curious. That is one major characteristic that I believe all scientists have. We are all curious. We all want to understand why the world is the way it is. Okay? And when it comes to psychological sciences, we're interested in specific aspects of behavior and mental processes. We may not necessarily be entirely interested in how the universe works, which might be, what a theoretical physicist might do. Nevertheless, we are still pretty curious about why we are the way we are. So, when scientists want to go about practicing science, we start our research beginning as a problem which we are seeking an answer for. So we have a problem or a question that we would like to answer. And so this is where we would begin. Now, when you have this potential question that you would like to ask, that you would like to find out more information about, some phenomenon that you are curious about, well, the first thing that a good scientist should do is review the past research. This is incredibly important. It is highly unlikely, if you are a scientist, that you are the first person to think of this particular concept as being interesting. And so you look and see what other research has been done on your topic. And from doing this past research, you're actually going to find potential gaps in the literature. You might find that maybe they did research on some kind of subjects, but maybe not. Maybe they've done the research on this particular drug on adults, but maybe not children. Something like that. And you would want to say, well, let's explore this further. Let's see if we can fill this gap. Let's see if we can find out more information. But to think that you are the first person ever to think of something is probably a bit arrogant. Other people have, and you look at the past research and you see what they have found, and you see what might be missing that you can follow up on. When scientists are trying to conduct research, what they need to do is they need to be able to think of the things that they are observing in terms of variables. They need to think of them as variables. A variable is anything that can have more than one value, or anything that can change. Okay? So, for example, height is a variable. If I took all the students in a classroom and measured their height, I would probably get different values for each person. One person might be 67 inches, another person might be 64 inches, another person might be 72 inches. Okay? And these would be the different heights of the different students in my class. Well, height is indeed a variable, can have different values. Okay? Self-esteem is a variable too. Some people might feel good about themselves, think themselves a worthy person, and they have high self-esteem. Another person might think pretty much down on themselves. They think that they're unworthy. They don't think they're any good, that they're not good enough. And they may have low self-esteem. So different people can have different levels of that particular variable. So what scientists try to do is they kind of break down the world we're looking at into measurable variables. That's the key. We want to be able to measure variables. Okay, so the next step, once you've observed your phenomenon and essentially observe observe the variables that you are interested in observing, you would then formulate your hypotheses and predictions. You would create specific testable predictions, and that's what a hypothesis is. And a hypothesis must be falsifiable. What that means is you have to be able to be proven wrong if that's the true nature of things. You can't just make a prediction that can't be proven wrong, then you'll always seem right. And you'll find that a lot of, if you look at maybe pop psychology, maybe stuff that isn't really scientific, they'll probably make a lot of claims that sound good but can't really be directly falsified. And you have to be very questioning of that. But hypotheses don't just come from nowhere. Hypotheses, at least when you are developing hypotheses, you should be thinking of a theory, thinking about what larger theory this hypothesis might fall under. Okay, if we took every single individual research finding, every single hypothesis, every single specific testable prediction, and we looked at the findings from it, and we just kept each of them separate without tying them together, it would just be a whole bunch of random findings that really would lack any kind of coherence. What the theories do is provide that coherence. A scientific theory takes a look at research findings from a particular area and essentially tries to build on it, tries to explain it, and tries to be able to put it all together in one big picture. Furthermore, it allows you to then predict future studies by using that particular theory. So a theory is a broad idea or a set of closely related ideas. It could more or less be something like an example, like one of the principles from operant conditioning. Behavior that is reinforced will be repeated. Behavior that is punished will be less likely to occur. These are some general principles in operant conditioning, learning theory. This comes from B.F. Skinner. Well, you could take a look at those particular statements. You can apply that to many, many different things. You can apply it to toiletry. Children who, get a little M&M after they successfully use the potty, they're going to be more likely to use the potty again. If a dog gets punished for peeing on the carpet, maybe the dog might be less likely to do it after the punishment, as long as the punishment came right after the doggy did it. So these are principles that can be applied to many, many, many different situations. And that's what a theory tries to do. It tries to explain it. Why does giving an M&M work at helping children be toilet trained? Well, because the M&M is reinforcing the behavior of using the potty, strengthening that behavior, making that behavior more likely to occur next time. And it makes predictions about future events. Well, if I can reinforce my child using M&Ms to use the potty, maybe I can give them M&Ms to, when they get older, maybe do the dishes. If they do the dishes, they get some M&Ms after doing the dishes. Maybe they could reinforce them to do other different things than that. And you can make predictions about future events. All right? Theories connect the observations with the research. So in other words, observations are just a whole bunch of facts, a whole bunch of things that you see. Facts, 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 facts. This is what you see. But just relying on that doesn't help us understand the world. You take these facts, measure, and then you make these observations. Perhaps you manipulate some variable, like you do in an experiment, and you see if that manipulation causes any change. And that's where your research comes in. So you conduct research, but maybe again a single research project doesn't explain the whole world. So a whole bunch of research projects that you can essentially tie together using the same principle. And I can tell you that there are thousands of research studies that use the learning principles, like the principles I discussed with operant conditioning, about reinforcement and punishment. Lots and lots and lots of research in many different areas of behavior and mental processes have applied operant conditioning. So that's just one example of a theory making connections between all those different research studies. And that's what good theories do. So Skinner's behaviorism, operant conditioning, a very good theory. It leads to many potential testable hypotheses. Many different research questions have been asked and answered as a result. Many future research studies can still be done using based on these principles. Okay. And when a study shows that your hypotheses are supported, it strengthens your theory. It shows that your theory has some what is called validity, has some truth to it. Okay? When the theories are not supported, but the results of your study, if you do your hypothesis in your study, and the results do not support your original theory, then you have to step back and question, well, maybe the theory is not quite right. Maybe the theory needs to be rejected altogether, or maybe it just needs to be modified. Maybe operant conditioning works in some circumstances, but not as well in others. And actually, there's some truth to that. If we learn more about that, you'll see that it doesn't always quite work the way the theory does. And that means the theory sometimes can be modified to account for that.